everyone. And I think you are very happy in paying the device. And as I said before, if you go back to your location, find a good installation page, and if you have a question on setup and configuration, please let me know. And if you have alternative or suggestions on the housing, please also share with us. Okay, before I move on to the next section, I show you a picture. Just take when we go outside. Do you remember this place? This picture is special because it's combined from several photos in different directions. So this picture shows the environment of the installation location. So it's good for our reference. You know, we are going to capture the human contribution to the night sky for our project. So we have to know the environment first. As I showed you before, the light curve in Hong Kong shows some drops in NSP, right? When someone turn off or turn on their light. So when we find these drops, we will look for the reasons. So one of the way to find the source of light pollution is look for the environment nearby. So if you are very familiarized with your countries and city, and you have some special lighting usage, we can the lighting usage will be affect the night sky. So I recommend you to take this kind of photos to see the different to see the environment of the installation location. Just here. So we know which direction has we know the direction of light pollution source from this picture. How can we take this? If you have just a normal digital camera, just turn to different angle and take pictures like this, and just set as this. Okay. If you have some software to combine the photos, or you use some smartphone apps, and they will they will combine the photos for you. Okay. Okay. Before I end this section, I would like to share to all of you the topic of so-called long night sky events. We talked about this morning, right? And I will show you how to deal with each component one by one. So remember, we have some factors affect the wall NSP reading. There are sunlight and physical readings, very small, very large, the aging of the the optical components, and the long routine lighting events, and some natural phenomena. So we define these kind of factors as long night sky events, and this will not reflect the general sky condition. Remember, especially for this long routine lighting event, they are real data, but not reflect the general condition. Okay, if you want to study how the Earth hour, for example, affects your night sky, you can extract that part of data and do an analysis. But when you are going to study the general condition of your city, you have to remove that kind of data before analysis. So, as I said, okay, first, the sunlight. And sunlight will saturate the sensor, so we move what can we do? We can simply remove the data taken before sunset after sunrise. Please note that normally the device will operate several hours before sunset and several hours after sunrise. So it will capture some zero reading data, meaning that the sensor has been saturated. And in this case, you have to know the sunrise and sunset time in order to remove that kind of data. Yes, right? So for every data, I will show you the database today or tomorrow. This comes with time. that means the time for measurement is important. So if you know the sunrise and sunset time, you can compare with the data time and remove the data taken under sunlight. So how to do that? Do you know how to find the sunset and sunrise time of your city? It's not that typical. If you are doing astronomical research, you should know it very well, or you can check it from the meteorological agency of your country, or you can go to some web interface to check the timing. For example, this timeanddate.com is not written by us, but some web resources. I find it very useful and simple. So, for example, if you want to look for the sunrise or sunset time here, so what should we do? We go to this website and type the city, Tokyo. Then it shows the sunset and sunrise time for this month. Okay, see this? So it's easy. So you see that normally the sunrise and sunset time won't change a lot within a short period of time. It depends on your altitude of your location. If you are closer to the equator, the sunset and sunrise times will be more or less, will not change a lot over the year. But if you live in some locations, so Mongolia or Korea or even North, then the sunrise sunset time will change a lot throughout the year. So we take note on this. I did it before. So for the twilight, similarly for the twilight, we have to exclude the data taken outside the astronomical dark period. And let me say again, the astronomical dark period is the time when the sun's altitude is when the sun is more than 18 degrees below the horizon. So theoretically, the sky should be free from sunlight and within the astronomical dark period. So we can check the time, and also we can check the time from the website we see before. This one, we go back. Actually, this page also tells you the astronomical twilight. These two columns, you see that? The astronomical twilight, that means that the start of astronomical twilight, the end of astronomical twilight. So within this two periods, for example, the 1st of January of Tokyo, the start of astronomical twilight is 5:30. What that means? That means before that time period, the sky is free from sunlight. 5 o'clock and 20 minutes. Then the end of astronomical twilight means that the timing is 9 minutes past 6. So after this time, the sky will be free from sunlight. So the time interval between these two timings is the astronomical dark period. Okay, so you should exclude the data outside this timing or outside this time window to avoid the sunlight, the effect of the sunlight. Also, it changes a lot, depends on the altitude of your location and the season. So actually, if you remove the data taken during twilight, you are also automatically remove the data taken under sunlight. So maybe we can skip this slide and just remove the data outside the astronomical dark period. Okay, easy. And then we discuss about the physical reading. I said that the device will sometimes give you a readings very small or very large, larger than 20 feet per second square. So you can remove them easily by excluding some rules in the database. I will show you not today, but later because it's easy. Then the light duration of optics and the aging of filter. For the aging, as I said before, we just ignore it because we believe that the filter won't force like the old models. So skip this. And the next one, the light attenuation. If you compare readings taken from different kinds of housing, you have to offset the wall NSB reading by minus 0.11 millimeter per second square, for example. Why? Because the glass window, we remove sunlight from the sky before hitting the sensor of SLE. So we have to adjust the value by certain amount, say 0.11 millimeter per second square. We minus the raw data, more data minus this small value. But why not plus add the value? Do you know why? Because remember that magnitude is the unit which have the properties that beta source will have a smaller value. So we believe that the gas will block some light, so we'll minus something, the reading minus something, in order to compensate the effect, to make it brighter, right? So we minus 0.11 millimeter per square. Well, if you are only doing the time variation, short-term time variation, I will show you tomorrow of NSB, you can forget about this for your analysis, because we assume that this offset will be constant. So if you are studying the short-term time variation of NSB, you don't need to subtract this value actually, because you can still study the variation of sky brightness. And please note that this value is not fixed, because we have measurement on this light attenuation of gas window, but our values is different from that of unihydron. So this value is subject to be further studied, and we may do this later. So for the long routine lighting event, as I said before, I invite all of you to provide the details on the long routine lighting events at your location, right? Since we not know the lighting event outside Hong Kong, we have a database for you to submit the record. It's not that difficult. Log in the database and type in the timing and the nature of the event that's finished. Then this list of long routine lighting event can be seen by each other. So if you are working on the light curve of other location, you should check the occurrence of long routine lighting event before analysis. And I will show you tomorrow how to input the record into the database. But I will show you this tomorrow. But I want to some points for you to look. And actually, it is not. How to say? If you are unsure whether it's long night sky event, maybe for example, suppose there was a stargazing event last night over this rooftop or the SQLE installed. Some people went to the rooftop to stargaze, but they may turn on their light. But if you think that the light is not so bright and won't shine on the sensor, what should we do? You can still report the event to us. Why? Because it is a record of the activities happen in your location. We have designed a field called readings effect for you to decide whether the reading were affected by the long night sky event. So I want to invite you to record that event even though it won't affect the data. In your understanding, it's for our information. So later, when we are doing analysis, and when we are doing analysis and when we are very, if we are want to avoid all the possibility of long night sky event, we can still have the chance to remove that kind of data. So I will talk about this how to input the long night sky event later. For the moon night, similarly for the moon night, we can check the timing from the website. For the timing for what? For timing for some moonrise and moonset. You see, you can go to this. Website. And type in the countries like Hong Kong. Then we get the table showing the moon properties of this month. You see, the moonset and moonrise. You should be very careful because these timings vary a lot within a short period of time. This doesn't like for the sunlight, the variation is not quite rapid, but for the moon properties, it vary a lot. So it's astronomical reasons. But for this, if you want to remove the data taken during moonlight, you have to avoid this timing, the timing within this time window. So, or you need a more sophisticated data on the moon. You can have, you can look the data from other software like this one. And I haven't, if you have time, we can share how to use this software because it's powerful. It can calculate many properties of the celestial objects, and for every conditions, not just the moon. Oh, for the lunar eclipse, the concept is the same. And I don't know whether you have seen the lunar eclipse before. Do you enjoy a lunar eclipse? The brightness of the moon will drop within a short period of time, and when the moon is under eclipse, you will turn red sometime. So the brightness drops significantly. It will affect our data. If you are not going to study the brightness of the eclipse of the moon with sky brightness, you can just remove the data taken during lunar eclipse. But it should be interesting. It's not interesting to study the sky change, the variation of the sky brightness during eclipse. If the weather is good, we have some example. Maybe I can show you later. But if you are not doing the eclipse analysis, or you are working on the moon analysis, that means the variation of NSV with moonlight, you should remove the eclipse data because it will pollute your data set. Because the brightness of the moon during eclipse is not that simple. So you can check the timing from your astronomy calendar or the website we see, or the website here. Actually, eclipse not happen so often, so you can check their occurrence like this. So the last factor is the scattered city light from cloud. And as I said before, the sky could be brightened significantly when the sky was cloudy. So what should we do? I ideally, you should remove the data taken during cloudy sky, right? But it's not that easy unless you have observation on cloud. Cloud amounts depends on location and time. If you want to study the correlation between amount of cloud and NSP, I suggest you to have a cloud observation just near or at the same location of the NSP observation to make sure that your cloud amounts truly reflect the real condition where the SQMLE observe. So, but it's not that easy, at least in our case, because cloud observation needs some professional to perform. And also, they have, I don't know whether you know that the units for cloud amount vary a lot. One of the units is called octa, octa, O-K-T-A. Octa is the cloud amount in terms of the cloud coverage from 0 to 8. 8, 1, 2, 3, 4, 5, so 0 octa means completely clear, and 8 octa means completely overcast. Somewhere between is 3 to 4. So it's determined by human, by professional, and they will report, at least in Hong Kong, report the cloud amount by about half an hour. So you see, in some cases, the cloud amount will change a lot within a short period of time. So we report some readings half-hourly, but it's not enough for the sky measurement. In our case, we measure the sky every 30 seconds. So unless the cloud is very stable, that means the cloud amount and the cloud optical properties won't change a lot. Then you have more data on cloud amount. So there is another device to measure the cloud amount, say a cloud sensor and ceilometer. Ceilometer is a device which emits the laser beam to the sky and detect the reflected beam to determine the cloud coverage and cloud optical properties. But it's not cheap, and if you can find some cloud data in your countries from or meteorological agency or some university who conduct cloud research, this will be useful. So if you are looking for a mountain location, and if you are going to study the cloud and NSP correlations, you may look for places with cloud observation, or you install a cloud sensor next to the SQMLE. So this interesting. We did that before. We find some interesting results, but maybe if we have time, we can share with you. But it's not that easy in some sense because cloud change a lot, and the cloud properties is not just cloud amount. It depends, the reflectance or the brightness of the clouds depends on the cloud base height, cloud type, and other optical properties. So if you just have a device to measure the cloud amounts, it's not that enough. But it's good for further study. Interesting. So another alternative is to, in case you don't have a cloud observation for every location, what should we do? We can do an average on a huge amount of data. What do we mean by average? That means after maybe you install the station for about 2 years every night. We have the data for 2 years every night. I think for such a long period of time, the cloud amount could be, you record the sky condition under every cloud condition. So if you analyze the data and find the average of these 2 years, the data collected over the past 2 years, it will give you an average effect of cloud. Do you get it? So the idea is that this is not a good attempt to study the cloud correlations or study the sky brightness within a short period of time because cloud change the sky brightness a lot. So in order to have in order to get a general saturation of the light pollution, you have to collect large amounts of data over a long period of time, so that you can get a general condition of cloud and the light condition, light pollution. Or as we see before, the cloud will the cloud will affect the data, and you see that from the light curve, there are some bumps or spark in the light curve. So we believe that they are caused by the small cloud comes in, then the cloud brightness, then the sky brightness will goes up, and when the cloud goes out, then the sky will be darker. So this kind of things will affect the light curve. So if you want to study the sky only under clear condition, you have to look at the light curve and check whether they have some fluctuation. For some, in our experience, if the sky was clear, the light curve should be flat, except some drop due to human factors, as we see before. So another alternative is to install a all-sky camera to observe the sky condition. You can't see the sky 20 hours a day, so you rely on some cameras to record the sky condition like this. There are lots of sky camera in the market, but I just show you one example. This sky camera is a small camera installed on the rooftop, and it has a fisheye lens to capture the sky condition continuously like this. So it gives you some ideas. What happens if the clouds roll in? So I have discussed a number of factors which reflect the sky brightness. Do you have any questions? This I think I won't give you a definitive answer to how to do your analysis. I'll just give you an idea what to do before your data analysis, and pay attention to these factors. It depends on your application. Okay, but we are not sure about the following events. For example, rings. The sensor put outside this ring. How the ring will affect the energy speed that we don't know yet. And the slow in Hong Kong, we don't know. We need your help. And the lighting. Okay, do you believe that this sensor can capture the lighting? Yes, it can. If the sampling frequency is high enough, or you are facing a thunderstorm, there's many lighting within a short period of time. But the lighting will give a very bright readings, right? If there are a lot of so-called unphysical reading there from the lighting, you can check the weather record. If you look at the light curve and see many sparks within a short period of time, and you know that at that night there was a thunderstorm with many lightings, so you will make sure that you capture some lighting event. But Nora, I have no idea. Yeah, also, and some birds and the tuna culture will sit on the sensor and leave something. Also, this is real pictures. This is an all-sky camera, as I said before, to capture the cloud amount, and this spider looks very big, really, because it's very close to the camera. So what if a spider if the spider just sitting on the sensor, how would the NSP change? I don't know. So maybe more, and some bugs come from the program. So I invite all of you to study their effect and share with all of us. They may be interesting. Okay, that's all for this section. So, any questions? I have one more sessions tomorrow morning. I will do some hands-on and stuff. I will show you how to download the data collect from all of us, and try to tell you how to analyze them for you to study the long-term and short-term variations of NSB, and you can I will show you how to do the cost-city comparison. Okay, thank you very much.